have the answer choices. I added them up here on the screen. So as we're doing it, you can see what the choices were. But in this one, you were told, this is not drawn to scale. In the figure, LQ intersects MP at point R. Well, we know that anytime we have an intersection of two lines, we create congruent angles. Why? Why are those congruent? Because they're the same. What are they? What's the angle type? What's that relationship? Starts with a V.
Vertical.
Vertical angles. Okay, vertical angles are congruent. Every intersection has two sets of vertical angles. So this set of vertical angles is part, those are part of these two triangles. So I can go ahead and mark those congruent. Now then they tell me that PQ and LM are parallel. The reason that's important is because back in, I think, Unit 3, we talked about parallel lines and a transversal. When you have parallel lines and a transversal, okay, you have all the angle relationships that we learned about. In this particular case, when we're dealing with triangles, okay, this creates a Z shape, right? This one's a backward Z, but it's still like a zigzag. When you create this zigzag between parallel lines, those interior angles are congruent. So L and Q are congruent. Now that right there, that's enough information to tell me these are similar triangles by angle, because I've got two sets of corresponding angles congruent, right? And I also, though, could have viewed my parallel lines with this as the transversal, and I would have seen that that other set of angles is congruent. M and P, right? Okay, so that's why it's important that they told us about those parallel segments. All right, so I've marked that up. Now the lengths of MR, LR, and RP are 6, 7, and 11, respectively. So when I look at this, we've had a few questions that had this wording. They listed something and then said respectively. That just means in that order. So MR, sorry, my pen stopped working for a sec. MR is the first one listed, so it's 6, the first number listed. So MR is 6. LR is 7. And RP is 11. So far, so good? So I know they're similar by angle, and they've given me some side lengths. So I know I can use proportions because in similar triangles, corresponding sides are proportional. If it is helpful to you, color code or write the proportionality with segment names. I don't know what's most helpful to you. Everybody's different. But for me, I like to color code. So for instance, MR, that goes from the green to the black, or the 3 to the 1. Okay, if you're color coding in colors, look at the colors. If you're just doing numbers of arcs, look at the numbers of arcs. But M to R would correspond to P to R, wouldn't it? Because that's 3 to 1 in this triangle. Do y'all agree? Okay. Now, another option, instead of just doing it like that, you could actually write your similarity statement. You could say triangle something is similar to triangle something and see the order of the letters. Okay, so if I named this first triangle LMR, remember the first one, I get to pick how I name it. The other one, I have to make sure it corresponds. So what was congruent to L? Q. So since I started this triangle with L, I have to start this triangle with Q. And then M was congruent to P, and then R to R. Okay, so you could write the similarity statement and look at it that way if that's helpful to you. And you can see that MR is in the same spot as PR. right? So you can look at it visually in the triangle or in your similarity statement, whatever makes more sense to you. Okay, now the other ones that correspond, the other side that I know is the 7. What side would the 7 correspond to? RQ here, because it connects LR is 1 to 2 arcs, RQ is 1 to 2 arcs. Or you could look up here, like I said, in the similarity statement and see LR is first last, QR is first last. Does that make sense? Okay. So now I know what corresponds to what. I'm going to label this I know 3 of these 4 pieces. I'm going to call that X, and I'm going to set up my proportion. Your proportion, you have options as long as you're consistent. Okay. So I could go blue to blue, yellow to yellow, or blue, yellow, right? So if I went 6 is to 11 as, so that's in the small triangle to the big triangle, the blue to blue. So I'd have to go small triangle to big triangle, yellow to yellow. So 7 to X. So that's one option. Or I could go blue to yellow in the small, then blue to yellow in the big. So I could do 6 is to 7 as X is to 11. That would work as well. And either one of those could be flipped if you flipped both of them. Notice when I go to do my cross multiplying in either one, I'm multiplying. Uh-oh. I should be multiplying the same thing. Did I mess up over here? 6. Oh, I did. Y'all, I did 6 to 7, which is blue to yellow. And then here I did yellow to blue. That's why that's wrong. Glad I caught that. That's why you got to be real careful, because if you're not consistent, I went blue, yellow. I got to go blue, yellow. So 11 to X. Because when I go to cross multiply, no matter which one I use, I should be multiplying 7 and 11. And then dividing by 6. Now 7 times 11 is 77. Divided by 6, it does not divide evenly. Look at your answer choices. They're all fractions. Is that my answer, though? Go back and read your question. Did it ask for RQ? What did it ask for? What is the length of LQ? So L to Q is this entire thing right here. So how am I going to find that? I have to add the X and the 7. Okay, I have to add these 2 pieces. I know LR and I know RQ. LR plus RQ will give me LQ, which is what I want. And I know LR is 7, RQ is 77 over 6. So I add that together, and you don't even have to worry about get a common denominator, add it. You don't have to do this by hand. You do get a scientific calculator, and it will calculate for you. So if you are wanting to do it by hand, you would convert the 7 into 6. So what divided by 6 is 7? 42, right? So I could replace the 7 with 42/6, and then I can add that, and it's 119 over 6. But you don't have to do that last part by hand. You don't have to convert that. The calculator will do this for you. Because I wanted to, 7 right now is 7 over 1. And I need to change my denominator to a 6. So I'm multiplying by 6. So I have to multiply the numerator by 6. So 7 times 6 is 42. Oh. But again, don't worry about that. Put it in the calculator. Are we okay with this one?
Yes, ma'am.
Okay, next one. We are given ABC, but nothing is marked on it. They tell us a bunch of stuff in words. We need to put it in the picture. Okay, so they tell me that D is the midpoint of AB. So I'm going to add point D here. And it's the middle, so it's bisecting AB. then it tells me that E is the midpoint of AC. So I add point E, bisecting CA. So far, so good? Now they tell us if BC is 24, and we dilate this triangle by a scale factor of 1.5, what will be the length of D prime E prime? What does that little prime mean? That apostrophe is prime, D prime E prime. What does that mean? The new one, right? The image. What we have here is our pre-image. We want to know after the dilation, what is the length of that going to be? Right now, what is ED? Right, but what is the length of it? How do you know it's 12? You're right. I want to know how you know. It's a, what's the name of that when you connect a midpoint to midpoint?
It could be phrasing Jesus right now.
Mid-segment. Okay, you have a mid-segment, ED, and we learned in Unit 4 that mid-segments are half the length of the side they're parallel to. So this is 24, means this is 12. Okay, so you had to know this from prior units. That's prior knowledge. So this is our pre-image. Now we're dilating it by a scale factor of 1.5. So if I'm increasing the size of this and multiple, you don't have to draw this, but if you are, if I'm increasing this by 1.5, 24 times 1.5 is 36. 12 times 1.5 is 18. And that's what they're looking for, because that's my D prime, E prime. That's the new mid-segment. Agreed? So your answer here is 18. Now, how you got that, some of you did this, or I mean, a lot of you didn't, because a lot of people missed this. But if you got it right, you halved the side to get the mid-segment, and then you multiplied it. So you took half and then multiplied by 1.5. The other option is take the 24, dilate it, then take half of that. So it didn't matter which order. If you took half, then dilated, or dilated, then took half. Either way, it gets you to 18. Does that make sense? We multiply by the scale factor. That's where 18 came from. Yes? Questions? Okay. Last one on this page. We have two triangles created by intersecting lines again. Okay, so this point C, we have vertical angles. And then we already have, oh, I should put two arcs there. Sorry, there's already one arc on A and D. So we have these two congruent, and then A and D were already marked as congruent. Is two sets of congruent angles sufficient to know that these are similar? Yes, angle, angle proves similarity. So I know these are similar triangles. So now I'm going to color code my corresponding sides. So DC, that goes from one arc to two arcs, would correspond to AC. DE, that goes from one arc to no arc, would correspond to AB. So I've highlighted which ones correspond to each other so that it's going to make setting up my proportion easier. Again, I could go green to green, yellow to yellow, as long as I go in the same order. I went left to right, or I could stay within my left triangle and go green to yellow, and then green to yellow in the second triangle. That would work as well. It doesn't matter which way you set this up. When you cross multiply, you're multiplying 15 by 20.6, aren't you? And then you'll divide by 24. Okay, so 15 times 20.6 is 309, divided by 24 is 12.875. I think a lot of you, maybe not a lot, some of you got this right, and maybe you messed up putting it in. Because I did get a lot of questions about how to input this answer. So I do want to just touch on that really quick. When you've got all these squares to type your individual digits of your number into, it doesn't matter how many there are. You can fill in your answer wherever you want without leaving space between your digits. So I could put it all the way on the far right, like that. That would work. Or I could put it all the way on the far left. That would work. Or I could put it somewhere in the middle and have blank spaces to the left and right. That's correct also. It's not going to count any of these wrong unless you were to do something like this. If you did 12 point and then left some space and did it like this, that's wrong. Because anything that's blank is filled in with a 0, and you're putting your 8 in your 100th spot instead of your 10th spot. You understand the difference? Okay, and I don't remember if this one had the plus minus box or another one, but anytime you have a box that's labeled plus or minus like this, that box is only for a plus or minus. Do not put a number in that box. So you could put the 12.875 like this and just leave that box blank because this is a positive number. If you put a plus sign, it's also correct. It's not going to count that wrong. This box is only for a plus or minus sign to tell whether the number is positive or negative. But if it's positive, nothing is needed. You can just leave it blank. We feel okay about filling in these boxes? Okay. That was the end of that page. Let me stop this video. It'll be a separate video. The first page is a video, second page is a video, and then we'll do the last page as a video.